Hello everyone and welcome in this course on the experiments in physics and informatics, chapter 1 on the laser and optical fiber. My name is ghemid mouna, an assistant lecturer at Teacher Education College, South City. In today's course, we are going to learn all about the basic of the laser and optical technology. The key points that we will address are a general introduction, the laser technology, in which we will detail on the laser characteristic, working principle and type. Then we will move to the fiber technology by introducing fiber structure, propagation mechanism, types and application in communication field, before we draw a conclusion. The mapping of this course is shown in figure. This map will help students more to focus on what's most important in this course. The specific objectives that students should achieve by the end of this course are: define the laser and identify its characteristic, explain the operation principle of the laser and the different types, explain the light mechanism propagation in an optical fiber, compare the different types of an optical fiber, evaluate the use of the laser fiber in communication field. As you know, the light has a dual nature as particle and wave. The light is an electromagnetic wave that covers the range from long radio wave through the visible out to gamma rays as shown in figure. These electromagnetic waves are typically described by any of the following three properties: frequency, wavelength, and photon energy. Consider a block of matter consists of atoms. When sufficient energy in the form electromagnetic radiation incident on this block in ground state, it transfers to excited state, after immediately return to ground state by emission of electromagnetic radiation. In this case, the energy emitted is incoherent. But there is a need to produce coherent light to some application, which is laser. The laser stands for light amplification by stimulated emission of radiation. This idea is proposed by Einstein to amplify the light using the energy released by atoms during energy level transition. This device is characterized from ordinary by the following properties: monochromaticity, directionality, coherence, spectral brightness, and focus ability. It should be noted that the light amplification takes place in three processes. First, induced absorption. Atom in ground state excited to higher state by absorption H. Second, spontaneous emission. Electron will return to ground state after 10-8 seconds by emission of energy H. Third, stimulated emission. An atom in excited state is stimulated by passing photon of exactly right energy. The atom returns to ground state by emission of two photons with same properties of direction and wavelength. The conditions required to achieve laser action are stimulated emission, population inversion and pumping energy, metastable state, and finally amplification process. Laser system consists of three main compounds: gain medium, pumping, and optical resonator. Active medium presents material of medium composed of atoms, ions, molecules. Laser pumping that provides external energy to the laser could be optical pumping, electric discharge, inelastic atom-atom collision, direct conversion. Optical resonator responsible for providing positive feedback and amplify the light through mirror that surround the gain. To understand more about laser working, you can use PhET simulator. This link is for short video as an example about laser action experiments. The laser device classified to four categories: gas laser used gas as a source and found application in lithography and microscopy. Solid-state laser used solid mixed rare earth as a source and applied in medical field. Semiconductor laser used semiconductor species as a source and found application in optical disc reading. Liquid laser used organic dye molecule as a source and found application in medicine and spectroscopy. In the next section, we will discuss on the optical fiber. The optical fiber are known as light guide, used in communication as waveguide. They are thin, cylindrical, transparent, flexible, and dielectric fiber. The structure of optical fiber consists of three layers: core, cladding, and jacket. Optical fiber work on the principle of total internal reflection, TER. The light propagates in fiber by multiple TER. This process could be occur if refractive index of core is higher than that of cladding and the incidence angle at core cladding interface is greater than critical angle. In fact, the light ray could be propagated in fiber through single mode, one path supporting one signal, or by multi-mode supporting many rays. Such a number of modes supported for propagation in the fiber is determined by a parameter V number, as given by this equation. Lambda wavelength of light and d is a core diameter. According to the number of mode and the refractive index profile, we can classify the fiber to three types. Step index single mode fiber has a core and a cladding with uniform refractive index and core diameter in order 10 micrometer. Step index multimode fiber has a larger core diameter and use laser and LED as a source. A graded index multimode fiber resembles step index multimode fiber, but refractive index vary radially. The fiber find application in all fields, especially in communication such as telephone cable. For example, in the simple point-to-point system of communication, the optical fiber acts as a channel like electrical wires, but transmit the information in form of optical waves. The figure demonstrates the simple point-to-point system that consists of optical transmitter that represent laser diode, communication channel, and optical receiver. As conclusion, laser technology has emerged as an attractive device with potential application. Fiber optic communication is a newer way to transmit information, and it's made through multiple technological innovation, including laser diode. Thank you.